Code problem 2770, maximum number of jumps to reach the last index. So we are giving an array of nums with positive integers. So let me check. It is not positive integers. It can be any kind of integers, positive or negative. But there is a range for the nums. And we are also giving a target. So we want to check if we can jump from the first index 0 to the last index with the condition of nums j minus nums I less than and equal to target, more than and equal to minus target. So this means if the distance, we can always jump from the left to the right. So from index 0, we can jump to index 2 if we meet the condition of the target 2. Target 2 just means absolute of 1 minus 3 or 3 minus 1, that is less than and equal to 2. So for example, we can jump from 1 to 3, or we can jump 1 to 2 directly. But we want to calculate the maximum number of jumps. If it is minimum, so it's gonna be different. But we're gonna check the maximum. So for the maximum, we can jump like 1 to 3. 3 cannot go to 6, but 3 can go to 4. 4 can go to 2. So we need 3 jumps for the maximum. If it is minimum, it is just 1 jump. So like this kind of a problem, we can use linear DP. But this pattern is similar like longest increasing subsequence. Basically, we need 2 loops. Let me explain a little bit from here. Let me explain a little bit in the whiteboard. Let me just choose some numbers. So for example, our target t equals to 2, and we have some numbers, just some random numbers like 1, 4, 3, and 2. So if we have an array like this, so we're gonna start from index 0, this position. So for this one, it cannot jump to 4 because the target is 2. We needed the absolute value of 2 numbers should be less than or equal to 2. So it means it can jump to 3. This is a 1 jump, and another jump is 3 to 2, because absolute of 3 minus 2 is less than or equal to 2. So at most we need 2 jumps. So that is the maximum. But how can we solve it? We can use linear DP like that. So for each of the DPI, DPI just means how many jumps we need until we jump from 0 to index I. So for example, from the beginning, the DP0 should be equal to 0. Why? Because we've already at the index 0 position. We do not need any jump. So DP0 should be 0. So what about next one, DP1? So for DP1, we have to check the previous value before this DP1. So index 0, there's just one index. So for index 0, it cannot jump to 4 because the distance is 3, more than 2. So we're gonna keep it. But what value we should keep? We should keep a negative infinity value. Because if you keep a 0, it will influence the next calculation. So maybe 2 to 4, the distance is 2. It can get to the result, because 4 minus 2 it is 2, and this 0 will plus another value will plus 1, it will be 1. So this is why for our initialization of the DP, it should always be negative infinity. You have to check. It cannot be 0, because this negative infinity means from the beginning you cannot reach any point. But for DP0, it should be 0. You should initialize like that, because you are already at the 0 index position. So for this one, you cannot jump. So the DP1 is still infinity. Because you cannot do anything. But what about the DP2? dp2 can jump from this one index 0. So dp2 will become 1 because dp2 should be equal to this one dp0 plus 1. Yeah, because you need one jump from this 0 index to here. Yeah, dp0 is 0, so dp2 is 0 plus 1, it is 1. Yeah, now we're gonna check this dp3, the last one. So dp3, we're gonna check one by one, we're gonna check the maximum. If it go from 3, it is 1 plus 1, it is 2. Yeah, so dp3 is 2. Yeah, so this is dp3, so dp3 should be equal to 2. Yeah, but we need to check the maximum. Maybe it can also jump from a 0 index. So dp0 is 0, so 0 plus 1, it is 1. So we're gonna choose the maximum of 2 and 1. So maximum of 2 and 1 is gonna be 2. Yeah. Now let me go to the code editor to finish the coding. So as I explained, I'm gonna prepare a dp, and from the beginning it would be infinity times n. N is the length of the nums. Yeah, and this infinity just means you cannot reach any point from the beginning, but you can reach 0 position. The index 0 should be 0. Yeah, it means you didn't jump. So, but you can have a number as 0. Now, we're gonna check one by one. So, for I, yeah, let me check if I can use I or j. I would use j. Yeah, because dpj just means the position I reach. Yeah, according to the description, I will change it to j. J is always more than I. Yeah, j is more than I. So I will make it exactly like the description. So for j in range should 1 to n until to the last index, n minus 1. And now we're gonna check the I before j. So it should be j minus 1 and minus 1 minus 1. Yeah, so this is a similar like longest increasing subsequence. Now we just need to check the absolute of j and I. So absolute of nums j minus nums I. If it is less than or equal to target, it means we can reach from I position to j. Yeah, so we can update dpj should be equal to the maximum, because we're gonna check the maximum result, maximum jumps. So it should be dpj with dpi plus 1. And finally, we just need to return dp minus 1 if dp minus 1 more than and equal to 0. Otherwise, we're gonna return a minus 1. Yeah, so the dp minus 1, it can be the negative infinity. If or we can check if it is not equal to negative infinity, it means there must be a value. Yeah, so we're gonna return dp minus 1 if it has a value. Otherwise, if it is the negative infinity, we're gonna return a minus 1. It means we cannot jump to n minus 1 index. Now let me run it to check if it works. As you can see, it works. Yeah, let me explain a little bit why we would prepare the dp like negative infinity. So for the case 5 testing case, yeah, let's check that. So if it is not negative infinity, for example, the target is 1, it means from 0, I can jump to 1, but I can never jump to 3. Yeah. So, but for this 2, index 1, if I didn't prepare a negative infinity, for example, if I prepare dp 1, yeah, if I prepare dp 1 to 0, so at this position it is 0. So 3 minus 2, the distance is still 1. It means I can reach this position. So here is 0 plus 1. Final result would be 1. But actually it is not, because you can never reach this number 2. But how can you represent you can never reach it? So I can use the negative infinity represent I can never reach at this position. So in this way, the last index would still be the negative infinity. So from here I can check it. If it is equal to the negative infinity, it means I'm gonna return a -1. If it is not equal, I'm gonna return dp -1. Now let me submit it and analyze the time complexity. As you can see, it works and it's pretty fast. The time complexity would be O(n) squared because we have two loops. Yeah, if you are writing the dp like the tabulation, normally the time complexity would be easy to analyze because you can directly check the for loop. There are two for loops. Yeah, and now let's check the length of n. So the n is just 1000. So that is why we can pass for Leetcode. Thank you for watching.